Hello students. So in this second part we'll be moving forward. Okay. So observable universe. Till now what we are able to observe from our scientific instruments, it is about 93 billion light years diameter. So that implies it is an isotropic spherical ball. Okay, so that having 10 to the power 53 kg mass, which is very huge, and isotropic means equal in all directions. Okay, equal spread in all directions as a spherical ball. So that is observable universe. Another point, that is cosmological horizon. What is cosmological horizon? It is a threshold beyond which beyond which we have not received light yet. That means there may be universes and objects beyond this threshold, which is nothing but 46.5 billion light years. This is the threshold. Nothing but half of this. Because it is a diameter, then it will be a radius. So beyond this radius, we have not received any light. But that does not mean that there are no universe beyond that. Okay, there may be other objects, but we have not received any light beyond that. Okay, so that is your observable universe. Now let us move to the key theories. Okay, the most famous one that we are going to discuss is Big Bang theory. Okay, so first let us take up Big Bang theory. So in the Big Bang theory, it was given by Georges Lemaitre in 1927. He was a great scientist, and what he said, that universe started with a big explosion from a point mass having infinite density and temperature. Okay, so this was his proposition, leading to expansion of the universe, which is still happening. Okay, which is still happening. Now he gave an analogy of balloon experiment. Analogy of a balloon. What he did, there was a balloon and he pointed some dots upon it, and he said when you blow it up, then there will be increase in the area and distance between those dots. That means not just the whole universe is expanding, but also the dots, that is the objects, are also expanding, which was later considered to be only partially correct, because studies show that these objects are not expanding, they are consistent. For example, the galaxies or stars, they are consistent at their place, they are not expanding as such. However, the whole distance between the galaxies is becoming greater and greater with time. Okay, so very important to understand Big Bang theory. Now there are some important features of this theory also. Let us move to those features. And features in the sense, what was the basis and what are the evidences, because this theory is the most accepted theory in the scientific world or scientific community. So Big Bang theory was based on few evidences and theories like other theories. Okay, what are the other theories? One is the expanding universe hypothesis. Expanding universe hypothesis. Okay, this was a very important hypothesis. Okay, it was given by Edwin Hubble. Okay, very important, Edwin Hubble. Okay, and he gave it in 1920s. In 1920. So what he said? He said that the universe is expanding and speed of expansion is rising with distance increasing. So as the distance is increasing, there was expansion in the universe at a higher rate. Okay, so very important expanding universe hypothesis by Edwin Hubble. And based on this, he also gave his Hubble constant. So this was the formula that he gave. S is equal to H naught D. H naught D is basically, H naught is Hubble constant. Okay, so as you can see, speed is directly proportional to distance. Higher the distance, greater the speed. So Hubble constant is there to create a relationship. Average value of Hubble constant is 67 kilometer per second per megaparsec. Okay, per megaparsec. You very well know 1 parsec is 3.26 light years, and you can have that value megaparsec, that means 1000 parsecs. So that is the particular distance with which we are calculating this kind of speed. Okay, so that is the Hubble constant that was given by Edwin Hubble. Okay, second assumption, second basis was the discovery of CMBs. CMB. So we'll see what is CMB. CMB is cosmic microwave background CMB radiations. They are very weak. Okay, what are these radiations? They have been detected. Some characteristic you should know about these radiations that are there in the universe. Okay, they have been detected now. They were detected in 1961. Okay, and what are the characteristics? They are weak radiations. Low temperature radiations. Low temperature radiations like minus 270 degrees Celsius, which is nothing but very near to absolute zero. Very weak radiations. Okay, you can see they are microwave radiations but very weak. Okay, and they are uniformly spread out across the universe. Okay, so what do we get from this? How do we understand that there was a Big Bang? This temperature is the deciding factor. Temperature, very low temperature, which is extremely low actually, and this temperature shows that they were probably generated at the time of the beginning of the universe. Okay, so very important that they were very early radiations. That's how they are of a very low temperature. Okay, in general other radiations are not of this much of a low temperature. Only these have been found to be at this temperature. Okay, and they are very weak radiations. So that clearly means that they are starting from very early time. That is why they have been absorbed throughout and very little of it is left, and they are uniformly spread out as well. This is also a very important thing, because as the universe is a ball like structure, so it is spread out in whole of the ball. Okay, so that is its major characteristic, which shows that there was a Big Bang. Now another evidence of Big Bang is that the prevalence of light elements. Light elements like hydrogen, helium, etc., many gases, and umpteen number of other elements also, that show that there was a creation of these elements in the form of a matter from energy. There was a Big Bang which was leading to creation of lot of energy as well as some matter also, because that energy was converted into matter somehow. Okay, so very important to understand that these light elements and other elements, they are present in the universe due to Big Bang. Okay, otherwise there may have been no such kinds of elements that were available. This is also a very important evidence. Another is the cosmic inflation theory, which was given by Alan Guth in 1981. This is also one of the evidence that there was a Big Bang. He said that there was, at the beginning of the Big Bang, there was a rapid inflation in the universe. At the time of Big Bang, there was rapid inflation. And it was so rapid that it was faster than the speed of light. In the beginning, it was very fast. It was extremely rapid, beyond the speed of